Okay, so we're going back to graphing inequalities. The reason we jumped to solving equations first is you need to have those skills in order to answer questions on solutions to systems of inequalities. So initially we learned how to graph inequalities, and then we jumped to solving systems of two equations, two unknowns. Now we're going to go back and talk about how to find solutions to systems of inequalities. Okay. Now if we're dealing with, let's just do one here. Make it. If I graph this, right, solid line, right, and then I have to shade. And the easiest test point to shade is 0, 0. So I'm going to put 0 in. Is 0 less than 3? Yes. So that means 0, 0 is included in this solution, right? Just a quick review on how to graph inequalities. Remember, there's 3 steps. Graph it like it's a line. Decide whether it's dashed or solid based on the inequality sign. If it's less than or greater than, it's going to be dashed. If it's less than or equal to, greater than or equal to, it's going to be solid.
I always forget that.
Yep. And then shade the side that makes that inequality true. And the reason we use a test point, because 0, 0 is very easy to go into any equation. And if it's true, then 0, 0 is part of the shading. If it's not true, then 0, 0 is not part of the shading. It's the other side of the line. Okay? What we're going to do in this section is we're going to add, let's just do a greater than, another inequality. Okay? So I'm going to graph it. Negative x minus 3. There's that. And it's going to go down 1 over 1, down 1 over 1, and so on. Oh, but I don't do that, do I? It's got to be dashed. Okay, and now I shade. Is 0 greater than negative 3?
Yes.
Yes. So 0, 0 is part of the solution. Okay, where the two overlap, the two shaded areas, is my solution here. Okay, that area here, from here going forever as it gets bigger and bigger and bigger, there's an infinite number of solutions here. So if I asked you, is 1, 1 a solution to this system?
Yeah.
Yes. What if I said, is negative 4, 1 a solution to the system?
No.
No, because it's not in the area that overlaps.
I don't understand that.
Well, think
It's
about
like
it. Find the point.
This is your area that's the solution.
Why can't it be
Negative 4, 1
Wait, negative. Oh,
is not in that area.
So for one of the textbook
Mhm.
things, it asked if like so 1, 2, 3, like negative 3, 0.
1, 2, 3,
Oh, wait,
0.
I'm sorry, 0, negative 3.
0, negative 3.
Right
Okay?
there. It
It's-
asked if
it's-
that was part of the solution.
It's dashed. So it does not include any point on the line because it's greater than, not greater than, or equal to.
Oh. Okay.
Okay? Because it landed on the dashed line,
I thought it was-
it can't be on that line if it's dashed and be a solution. Because it's greater than that. It
So
can't be
if
equal
it
to
was
that.
Like, that
0,
one?
3, yes, would be.
Okay. Darn.
Yep. Okay. So what WebWork is going to do to you now is they're going to throw in something like 2 more. 2 more. And all this does is it puts bounds, potentially, on this one. Let's see if it puts bounds. So if I say x has to be greater than 0, so if x is greater than 0, it's going to be everything here, right? And y has to be greater than 0. So my bounds are going to be this, this, up here. But in this case, because I don't have a line over here, this is unbounded.
Wait, what's unbounded? The left of that?
The solution of this whole system.
So if they said that it was less than or equal to 0 and y was less than,
Let's do that one. That would be better. If y is greater than 0, let's leave that one. Let's change this one to less than or equal to. and x is less than or equal to 0, it's going to be that piece right there.
That's bound.
That would be a triangle that it's shaped, because it's everything in this region with
Okay,
these
so
two.
Because that one was like open up, it wasn't fully closed. It was
It's unbounded. Okay,
So
but now it's
a
bounded.
Closed shape, it's bounded.
Yep, and it'll ask you, like question 1 says something like, someone have it up?
Yes, right here.
What is the first part?
The feasible region.
Yeah, the feasible region. So it wants a shape. So in this case, my shape would be a triangle.
Talking about web work?
Uh-huh.
Yeah.
My shape would be a triangle. Then it asks for you to name the points of the vertices of this triangle. This one's pretty easy, right? It's 0, 0, 0, 3, negative 1, 0. And it tells you, you put the smallest x value first, so that would be negative 1, 0. Then you go clockwise, so it would then be 0, 3, and then back to 0, 0. Okay? Now, if my bounded region happened to have this point, we can't tell from this graph what that point is. Now we're going to use the skills we just learned on solving systems of equations to find that point of intersection.
That's gonna be so long.
Okay?
Like
It's not.
a problem.
So if I wanted to find this point of intersection, and it's already in slope-intercept form, one way I could do it is just set those two equal to each other.
Like this
It's
one.
basically substitution. If y equals this, then I'm going to substitute this in for y here. And so I just set these two equal, right? There are. So all I'm going to do is set those two equations equal to each other and solve. 5x equals negative 6. X equals negative 6/5. So I know the x-coordinate here is negative 6/5. To find the y-coordinate, just put it back into either one of these.
It is, huh, 'cause it's like,
Put it back into either one. So if I put it in here, that would be 6/5 minus 3, or 6/5 minus 15/5, which is negative 9/5.
On question 1, when they ask for the feasible region, are you talking about the bounded?
You put the shape in. Is it a quadrilateral? Is it a triangle?
Oh.
Could you do
You put the shape in.
one trick where you times everything by 5 to find out?
So
would that
with the
not work
fraction
there?
That's elimination? Wait.
No,
Where
because
you
I don't have an
Where you
equation.
times everything.
I could. If I said y equals this, then it would be 5y equals 6 minus 15, right?
Okay.
And then I'd add, 6 minus 15 is negative 9, so y equals negative 9/5.
Oh.
Yep, it would work.
this stuff is complicated.
Yeah.
Okay, now another one of there's only 6 problems
Yeah.
because it is complicated. Another question you might have is something like this. And it wants you to actually identify the inequalities that represent this bounded region.
There's probably a rough to do that.
So let me talk you through how to do this, because you're going to have a problem like this on WebWork too. So the first bound is this line down here. Is this a y equals line or an x equals line? It's a y equals line,
Oh, yeah.
right? And it is actually y equals negative 2, right?
Yeah, 'cause
Okay, now, it's an inequality because it's shaded. So the inequality shows shading above negative 2. So what do you think this symbol should be?
Y is
Greater than or equal to.
yeah.
Greater than or equal to. So I found one bound.
Oh, why that takes me so long.
Now, to find another, what I'm going to do is look at this line. Okay, I'm going to find 2 points on the line that looks like it goes through.
Yeah, right there, yeah.
Okay, I'm going to label the points. So this is 1, 2, 3, 4, 5, 6, 7, 8. 2. 1, 2, 3. 1, 2, 3, 4. No, sorry. 8, 0, right?
Yeah, I thought that was your.
Yeah, that's my x-axis.
Oh.
I know, I did the same thing. 1, 2, 3, 1, 2, 3, 4. Okay, I have my 2 points. Now I know how to make the equation of a line. Okay, so I do 4 minus 0, 3 minus 8, so the slope is negative 4/5. Okay, plug in a point. I'll plug in 8, 0.
Wait, we can't.
Okay, so this becomes negative 32/5. Of course, I picked a really tough one. So B is 32/5. Okay, so I have y equals negative 4/5 x plus 32/5. With me so far? This is just finding the equation of a line. Okay, in WebWork, all of your equations are going to be standard form, not slope-intercept. And in standard form, we can't have any fractions, right? So I'm just going to multiply everything by 5. Right? And now I'm just going to move the x term over. There it is in standard form. Now you can go in WebWork and you can pick the one. There's going to be 2. One's going to be greater than or equal to. One's going to be less than or equal to. How to figure it out? Well, let's look at this one. If I don't know what this needs to be, I put 0, 0 in for x and y. Everybody following? I promise you guys are going to struggle on this if you're not watching this to know how to do it. If you're working ahead or trying to get it, you're going to have questions. So I want to make sure you understand how to do this. You're going to put 0, 0 in for y. Is 0 greater than or less than 32?
No.
Greater than or less than?
Less than.
Less than. So I know that's going to be the symbol.
Oh.
That's how we find that equation. Then you do the exact same process for this line. Find the equation, match it in WebWork. A lot of times, by the time you've gotten this equation and this equation, there's only one left, and you just have to pick whether it's less than or greater than. So you can, again, just use 0, 0 and see which one it should be based on your graph. So you really should only have to go through this long process one time to find one of these 2 lines. The other will be obvious because it's the only choice left. And then you just have to pick whether it's less than or greater than. Okay?
That's a lot.
It's a lot, but that's why there's only 6 problems. Okay, so see if you can get a couple done while I'm here to help you. And it will close tomorrow at midnight, so you've got time in class tomorrow to ask questions too.